Side, side, side postulate. SSS stands for side, side, side. Okay, I'm recording. Okay, side, side, side. So if three sides of one triangle are congruent to the corresponding sides of another triangle, then the triangles are congruent. So if this side is the same length as that one, these two sides are the same length, and these are the same length, then we can say they're congruent. Now when you list them, we have to put them in order. So if A and B is our first side here, DE has to be our first side here. And then we put C and F, and we can say that they are congruent. Okay, so that's the first postulate that tells us that triangles are congruent, side, side, side. The next one is that if we have two sides, this is called side angle side. Okay, it's two sides and the included angle. So what that means is this side is congruent to that side. These two sides are congruent, and the angle between them has to be congruent. It can't be an angle over here or here. It has to be the angle between the two congruent sides. So it's the included angle. So it goes in order, side, angle, side. Like as you move, side, angle, side. If we have that, then the two triangles are congruent. So would be the same thing. We need to put them in order. So if B and E are the congruent angles, it has to go in the correct order. That's an E. If these angles weren't marked, okay, let's say those two angles are not marked, and just these two sides are marked, I can't prove that these are congruent. But with these, even though only two sides are marked, because this side is the same side, then because it's the same as itself, we know it's the same, so this is side, side, side. Does that make sense? Okay. So that's the only time this is the only situation where you don't need three things marked. Like with a side. Or at vertical angles, if we know vertical angles are congruent. So if these two triangles were like if this one came down around like that, and so it was like an X, then I would know that these two, the vertical angles. Does that make sense?
I would be sure those are the same length though. What if one of them is like a millionth of a second?
Because it's marked.
No, I mean in the bottom right one.
No, because it's the same side. Like it's equal to itself. Everything's always equal. You're equal to yourself.
But how can we be sure?
And I'm equal to myself, and that line is equal to itself. The Elmo is equal to itself. The cup of tea is equal to itself. Everything is equal to itself.
Tea smells really good.
Thank you.
Is that bisymmetric or whatever?
Reflexive. Yeah.
So, like, if you're trying to prove that the triangles are congruent, like in the reasoning, can you put like?
We're going to say, what does X have to be to make these congruent, right? And then what would be the congruence postulate?
SAS.
SAS, right? Because side, angle, side. Does that make sense?
Yes.
Okay, how about this one? What does this have to be?
35. Okay.
35, 35, right? So 28, 28. Now, this one we could go two ways. By putting this side in, we get side, side, side. Although we could also say side, angle, side. We could prove this congruent two ways because those are vertical angles. So we could say, this is one of those ones where you could do two different things. We could say side, angle, side, or we could say side, side, side.
Why is that one side, either side, either side?
Because of the, wait, which one? This one? See, these two angles are the same, right? And this side here is the same as itself. So when we said that X had to be 9 to make this true, that gave us side, angle, side.
How can the second one also be side by side?
Well, it's really side, side, side is what they were looking for, but because these are vertical angles, then we also know that they're the same. So this could be, if you didn't see side, side, side on a proof, but you saw that the angles were the same, this one could be side, angle, side. You could prove it two ways. And sometimes you can. Like you can go side, 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 or side, angle, side, or something, and they both be correct.
Depending on how they shape the
Depending on what statement you said before that. Like if I said this angle was congruent to this angle because of vertical angles, then I would use side, angle,
So
side.
if there was no vertical, then you could just put SSS.
Right.
There's no way to indicate they're the same angle.
Right. Does that make sense? Okay. So, okay, if you need to draw the triangles, you can draw them. A, B, C, and K, L, M, as long as you put them in the same order, right? So AB should be the same length as KL. BC should be the same length as LM, and AC and KM should be the same length. So we just need to find all of those lengths. So I'm going to do AB first. -3 minus -1 squared plus 3 minus 3 squared, that's plus 1. So that's the square root of -2 squared plus 0 squared, which is just 0, so not even. Which is the square root of 4, which is 2. KL should match. So I have 1 minus 3 squared plus 4 minus 4 squared, which is 2 squared. So it matches. Did you guys follow? Like I didn't have to do all the work, right? Okay, so these two are good. So now I need to try BC. As soon as if you find one that doesn't match, they're not congruent, you could stop. So we may not even have to do all of the sides.
Wait, if you do 2 and they're congruent, you can stop?
No, if you do one that's not congruent, that don't match, then you know they're not congruent, so you can stop.
I see. So you just do the distance formula for each set.
Each side, yeah, each set of sides, and if you find one set of sides that doesn't match, then you know they're not congruent, so you can stop. Yeah, but if they keep matching, you have to do all 3 of them because it has to be side, 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 right? So, so I did -1 minus -3, so 3 minus 1 squared. That gives me -1 plus 3, which is 2 squared, plus 2 squared, so this is the square root of 8. LM, I have 3 minus 1 squared plus 4 minus 6 squared, which gives me, oops, wrong symbol, 2 squared plus -2 squared. 4 plus 4 is the square root of 8. So far we're good. So I have one more set of sides to check, AC and KM. So -3 minus -3 squared plus 3 minus 1 squared, 0. And 2 squared. And then KM, I have 1 minus 1 squared plus 4 minus 6 squared, which equals the square root of -2 squared, which is 2. They are congruent. And they're congruent by side, side, side. Okay, everybody should get this one. Ready? Given. Thank you. PT is congruent to DF. Good. Go ahead, tell me. Awesome. Okay, angle R is congruent to angle E. And angle T is congruent to angle F. Okay, now this angle would tell me angle side, side, but remember there are no angle side sides. So I have to either find a way to prove that these two sides are the same length to give me side, 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 or a way to say that these two angles are the same. Which one can I do?
RT and EF.
How would I be able to say those are the same though?
They're vertical.
No.
You could say DE equals to PR, and then
There, we already have that. It's right here.
Yeah, John, and then, I don't know, trans.
Here's what we have, okay, guys? We have the ability to use side, 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 or side, angle, side right now. So I either have to prove that angle P is the same as angle D, or I have to be able to say that angle side RT is the same as side EF. Which one can I get to?
PD, because you just need the angle.
PD, right? Because I have these two angles, triangles add up to 180. So if I can say that angle P is equal to 180 minus angle R and minus angle T, right? So triangle angle sum. And I can say angle D is equal to 180 minus angle E minus angle F because of the triangle angle sum. What do I know about R and E?
They're congruent.
They're congruent, so I can take one out and put the other one in. And T and F, same thing, right? For substitution. And now look at this. These are the same, so that makes those the same, yeah? And now I have what? Why are the triangles congruent?
Because of SAS?
Oh, yeah.
They have angle side. Now, we have AB and CB are the same. That's all we've been told. Okay? Oh, sorry, and that D is the midpoint of AC. So I have statements, I have reasons. What does it mean for something to be a midpoint? It's the halfway, yeah. So that would mean that AD is equal to DC, right? Because that's the definition of midpoint. So that would tell me that these two are the same. And what do I know about this angle to make it the same? Or not angle, line. Yeah, it equals itself, right? It's reflexive. So now how do I know the triangles are congruent?
Side, side, side.
Side, side, side. Have angle, side, angle. Let me draw you some triangles. See, and that's how I know they're congruent, because I copy and paste. Okay, so angle, side, angle is if you have an angle and another angle, and the side between them is the same length. So this angle, and the side between them tells you that the whole thing's congruent. And then you have angle, angle, side. So if I have this angle and the following side. Okay, so what we have so far, we have side, 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 angle, angle, and angle, angle, side.
So is ASS the only one that will work?
Yes, so far. You can't have ASS. No, actually, it's not. It's not that they just, guys. These are only for right triangles. So you know, right triangle has 90-degree angle. No, come on. Stop.
Try grabbing it from the triangle.
I'm trying. There we go. Sometimes it doesn't like to cooperate with me. Okay, so we have a right triangle, right, which means we have a 90-degree angle. Okay, hypotenuse. Remember the hypotenuse is the long side. So if you have the hypotenuse and either leg, you're congruent. And if you have the hypotenuse and either angle that is not the right angle. So basically this is the same thing as angle, angle, side, right? So as long as you have the hypotenuse and one leg, or the hypotenuse and one angle that's not the right angle, you're also congruent. To recap, our congruency, we have side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg, and hypotenuse, angle. That's all of them. This is not, guys, shh. So this is what? I have an angle, I have another angle, 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 side. Here I have angle, side, angle. Here I have hypotenuse and a leg. And here I have hypotenuse and an angle. Now to tell which one is the hypotenuse, if you look at the corner of the right angle, it points to the hypotenuse. So you can always tell which one is the hypotenuse that way. So the right angle points to the hypotenuse. A couple of them we could use here. We have a hypotenuse and an angle, right?
So, yeah, hypotenuse leg.
Not hypotenuse leg, hypotenuse, angle.
Oh, yeah.
But I can also say angle, angle, side. Technically that's true, right? Angle, angle, side. But look at this. These are vertical angles. So I could say angle, side, angle. So there's more than one way to get there, right? No.